All right, you are welcome again. We want to talk about limit. And under limit, let's take a look at this question. It says, prove that limit as x approaches 0 cos 3x minus cos x all over cos squared x minus 1 is equal to 4. Hello, we are asked to prove that when we evaluate this limit, cos 3x minus cos x all over cos squared x minus 1 is going to give us 4. You get it? Good. Now, let's see what we are going to do. In a numerator, where we have cos 3x minus cos x, what are we going to say or what are we going to do about it? Now, recall that one of the trigonometric formula, it says cos A minus cos B. This is called factor formula. Factor formula. You say that cos A minus cos B is equal to minus 2 sine A plus B all over 2. Hello. Minus 2 sine A plus B all over 2 times sine A minus B all over 2. So we see that cos A minus cos B is the same thing as A minus 2 sine A plus B all over 2 times sine A minus B all over 2. In this place, in our numerator, we have cos 3x minus cos x. So we can take 3x as our A and then x as our B. So here we have cos A minus cos B. All right, good. Now, if you take it to be like that, that is for numerator. Then we also go to our denominator. Now, denominator, we have cos squared x minus 1. And then you remember trigonometric identity, where we say sine squared x plus cos squared x is equal to 1. Let's make sine squared x the subject. So when we make sine squared x the subject, we are going to have 1 minus cos squared x. Hello. Now from here, let's multiply 2 by minus 1. If we multiply 2 by minus 1, we are going to have minus sine squared x is equal to cos squared x minus 1. Hello. We are going to have minus sine squared x equal to cos squared x minus 1. And then in our denominator, we have cos squared x minus 1. So we are going to replace this cos squared x minus 1 with this value minus sine squared x. Hello. Now let's go. If we substitute in this our numerator and in our denominator, that means we are going to have limit as x approaches 0. In place of cos 3x minus cos x, we are going to replace it with minus 2 sine 3x plus x all over 2 times sine 3x minus x all over 2. Hello. It's still the same, right? All over. In place of cos squared x minus 1, we replace it with minus sine squared x. You get it? Good. So in our numerator, we have minus, and in our denominator, we also have minus. So this minus can go, right? Good. So that means we have limit as x approaches 0. 2 sine 3x plus x all over 2 times sine 3x minus x all over 2 all over sine squared x. So inside the bracket where we have sine 3x plus x all over 2. So when you say 3x plus x is equal to what? 4x. And then 4x divided by 2 is equal to 2x. All right, good. And then in the other bracket, we have 3x minus x all over 2. So 3x minus x is equal to what? 2x. And 2x divided by 2 is equal to x. So here we have limit as x approaches 0. Let's take 2 behind limit. Okay, so here we have sine 2x times sine x. Hello. Now we evaluate 3x plus x all over 2 and it gives us 2x, and then 3x minus x all over 2 gives us x. So here we have sine 2x times sine x all over sine squared x. All right, good. So here we have 2 limit as x approaches 0 sine 2x times sine x all over sine squared x. You get it? Good. Now let's go. Recall that whenever we have sine 2a, sine 2a is the same as saying 2 sine a cos a. Hello. Whenever we have sine 2a is the same as saying 2 sine a cos a. Now in this place we have sine 2x. In this place we have sine what? 2x. That means it's going to give us 2 sine x cos x. It's going to give us 2 sine x cos x. And then we also have times sine x. So here, after replacing this sine 2x, we have 2 limit as x approaches 0, 2 sine x cos x times sine x. Is that true? Yes. So in the numerator we have sine x times sine x. So multiply this is going to give us sine squared x. So here we have 2 limit as x approaches 0, 2 sine squared x cos x all over sine squared x. So sine squared x in the numerator divided by sine squared x in the denominator going to give us 1. So they will cancel out, right? Good. You are going to be left with 2 cos x. So here we have 2 limit as x approaches 0, 2 cos x. Let's fix in 0 in x. So we have 2 cos 0. Cos 0 is equal to 1. 1 times 2 is 2. Multiply by 2 behind the limit. We have 2 times 2 equal to 4. So therefore, we have seen that limit as x approaches 0, cos 3x minus cos x all over cos squared x minus 1 is equal to 4. Hello, is equal to 4. Yes, thank you very much for watching. Please, if you are new to our YouTube channel or you are yet to subscribe, please, we beg and we plead with you, click the subscribe button, like and share our videos. Stay blessed. See you some other time.